Okay, I have Raspberry Pi. All right, so I wanted to set up a Raspberry Pi and also PNC. Basically, yeah, some of you may be confused when I ask you to do PNC, or some in another way, I ask you to get a terminal. Um, those who already tried, you may be able to see that Raspberry Pi itself, there's no user interface at all. Only CPU and processors and some of the ports, right? It has Ethernet ports uh, and four of USB ports, audio and video power lines, and SD card, um, the placeholders. So many such things together with the 40 pins, right? GPIO pins, general purpose input and output ports. The pins are available. Uh, so you need to set up the Raspberry operating systems. Raspberry operating systems are basically kind of Linux. Uh, on my video, uh, I recorded how you can install Raspberry OS on the SD card. Okay, so you need to follow the procedures because you have to first to clean up SD card and also um, to build that SD card as a the boots. So first to when you turn on your Raspberry Pi, operating systems should be read from your SD card. Although your microcontroller Raspberry Pi has a ROM, right? So that there is a bootstrap first initialized, and from that bootstrap, your operating system is loaded on your RAM memory. So everything looks fine up to that point, but because there is no input and output. So inputs that we usually use the mouse and keyboard. So you better have extra USB enabled keyboard and mouse. And also because there is no terminal that you can see what's going on, so you need an extra terminal. It could be your TV if you do not want to buy any additional terminals, of course, right? Initially, you may be able to see uh, that Linux box, Linux systems, right? And you need to set up Wi-Fi to connect to the internet, and also you need to open up terminals so you may be able to do some of the codings and all other Linux things. Those who do not have a Linux command, I have another video clip prepared for you to learn something essentially that you need to know while you are working on Raspberry Pi. So I'm going to show that to you. Um, and also, if you do not want to use that extra terminal all the time, but because you guys have a laptop, another good attempt is to use your laptop as a monitor to your Raspberry Pi. So you need to install VNC viewer on your laptop. There are, depending upon your platform, if a Windows version or Mac versions of a VNC viewer is possible. So you need to install it. Meanwhile, your Raspberry Pi needs to communicate the VNC. So there's some other steps that you have to configure, right? So follow that. Since your laptop and your Raspberry Pi are connecting to the same router, your home router, so looking at IP address for both of your, particularly your Raspberry Pi IPs. So from your laptop, you need to find out, you need to enter that the IP, specific IP that you want to view remotely, and then connect it to your Raspberry Pi. From that point, you may not need your extra terminals. Unless you change Raspberry Pi, the router, unless you change the router, right? As far as you are working on the same router all the time, then you will be fine. Your laptop always may be able to see your Raspberry Pi. So your Raspberry Pi does not need to sit next to your laptop. It could be anywhere at your home, as far as it is connecting to your router and your laptop connects to your same router, then and all the time you can see your Raspberry Pi Linux box while you are working on your platform operating systems. That's what we had. I'm trying to summarize all to see if you are on the same page. That's what we did here. And up to this point, anybody has any question? Okay. Therefore, I ask you to do the homework number 2. And then I have here text to, those who purchased text, you can refer to that. Chapter 2 and chapter 2, 2 chapters are posted here. And there are many other chapters that's for iPhone apps developments that I would not post here, but this is for the sensors and those things. So you can use that. And then this is today's slide. And all of those, not all of those. And today's what we are going to do is, I believe that is, I think this something, the coding, right? So this is something that we want to do today, right? Sensor, you have to first to understand the pin numbers. We have 40 pins, okay? Of course, this guy has SD card, so your operating system is loaded into your RAM, and you might have some other USB and this Ethernet. You do not usually use this Ethernet, but when you want to set up your Raspberry Pi as another router, okay, then you can connect this to your router. So you have your home router, and then you have a sub-network. So you have another router inside your home router. There you can be able to catch up all the network packets very handy ways. But that is another stories. But anyway, so these are the pins. So we have 2 pins for 5 volts and 2 pins for 3 4.3 volts. There are pin numbers 1, 2, 3, 4, 5 up to 40, and this inside the number we have two different numbering systems. Inside here, on the green background, right? And another pin numbers outside, like that we have here, GPIO2, GPIO3, which is, in other words, SDA1, SCL1, GPIO17, and GPIO5, 6, 26, and there is also ground. There are many grounds. 1, 2, 3, 4, 5, 6, 7, 8, 8 grounds. This ground common to your green label here or external labels. It's called that PCM labels or board labels. You may be able to see that later. So ground pin number 6. If you are following this board mode, still pin number 6 will be the ground. Depending upon your sensor, if a sensor requires 5 volts, then you can supply the power from pin number 2 or pin number 4. If your sensor wants the power 3.3 volts, then you can use this pin number 1 in green or pin number 7 in green. Other PCM mode, those designated pins, for example, 34. 34 is always ground for PCM mode, and also 34, pin number 34 will be the ground on board mode. We have two different modes. Here, if you want to configure your Raspberry Pis using serial peripheral interface, serial communication, then you have to enable it, or you can reboot something else. You don't need to do this always, right? In general, yeah, you have to enable this SPI interface. If you go to, if you do sudo Raspberry Pi -config, inside you can set it up. And then you have to reboot. And you don't really need here number 3, step 3. So basically what you need to do when you have a sensor and when your Raspberry Pi is ready, then you need to wire. So let's say this is a breadboard. On breadboard, you can place the sensor into the slots here. This breadboard has basically 5 holes at one side, another 5 holes at another side. So it has a hole numbers. There are holes. So in this direction, the holes are inside connected. So these 3 holes are those holes are connected. Okay, in this I don't know what this is not vertical line, but slanted vertical lines, right? From upper right to lower left direction, they are connected. And this side, they are also connected. Outside, we have 2 lines, and sometimes it is colored red and blue, or sky blue. So blue and red. They're all connected on this direction, from upper left to lower right corner. They are all connected inside. So if you plug here this jumper cable and plug the other, then that is automatically connected. So that you have to be very careful. If there is a power lines or there is another ones, then there may be spark, right? So you have to be very careful. Because this is a low voltages, it doesn't harm to our human body. We do not really feel, but sensor itself may die, right? So you have to be very careful. When you supply the power to the sensor, you have to be very careful. To practice it, we're forced to use LED lights. This is a light bulb that is connected. So this line goes to somewhere here, pin, and another line goes to another. And this LED lights may be one leg connected to this blue line, another leg may be connected to this red legs. We have one pin connected here. As I said, those whole lines, all the holes along these lines, they are all connected. So if you plug one of the leg from this LED into any hole on along that lines, then that means they are connected. So it means you simply connect this blue line to one of that leg of LED technically, right? So you can connect and disconnect very easily by simply plug in the pins, jumper cables into that holes. So those the jumper cable here and the leg pins into the holes, they are all lined up along that lines if you want to connect. If you put that leg into another the holes in another lines, then that means they are not connected. But anyway, so wiring is first step that you have to do. And then you have to scripting. You have to code. Code usually given, okay, and on this sensor networks. And then you have to execute it. Usually given means when you purchase a sensor, then you have to be very careful where there is a Python code available. Of course, when you receive a Python code, you have to be very careful. For example, here, when you set up pin number 21, there's a GPIO output. And then set mode, GPIO.BCM. This is a BCM mode. Although there is a board mode, as I said, board or BCM. If you have a BCM, on your code, if you say, hey, I want to use a BCM mode, then all the number here, 21, it has only 21, right? 21, pin number 21 always says BCM, so 21. Where is it, GPIO 21? Yeah, GPIO 21 here. You have to look at this, 21, 20, 16. If you are using board mode, then 21 will be this. Okay? That thing that you have to be a little bit careful, right? Here. Yeah. And I labeled here any number on the green color background are the numbers of board mode. Any number outside, then that is a BCM mode. I indicated that. And the previous, the code, this code, because we set up 21 pins for the LED lights. So long lights receive the power and short leg that is the ground. So short leg goes to ground here. We are looking BCM mode, so you can use this ground, this pin, or you can use this pin that is also ground, or you can use this pin, right? Or you can use these pins. There are a lot of ground pins. And then this long leg of this LED lights, that should be GPIO 21 according to BCM mode. So come back here, then we set up 21 for that LED. And if 21 is true, it means lights on. If it is false, then lights off. So lights on and off. That's what we are trying to do here. Similar things that we do board mode. Okay, that is board mode. If you want to use, if you do not want to change this pin number 21, that's fine. Okay, code is not changed. If code is not changed, but you change board mode, then you have to change the wiring. So it goes into this, according to board mode, pin number 21 is here. There's a pin number 21. It's not anymore here. It goes into this pin number. Okay. Ground could be any ground. Like this. By the way, resistance could be used. The reason that we use resistance, if there is any overload, power may not be stable, then this sensor will be dead, right? Will be broken. Therefore, resistance may be used. You can use this resistance from the one of the pin to ground, or you can use this resistance to the power lines. But this is recommended. That's what we do, and distance sensor and many others that I wanted to look at. But I have here the videos. Okay, I already recorded it. Line deeper and deeper. LED on piece. Let me see if you can hear. Probably you cannot hear. Yeah, in this way you may be able to. PCM mode. Yeah, right. That's this page. And the next page is. So I want you to follow this. I'm not going to show this to you. And in the middle, the reason I recorded this offline is some of the resistance. As I do here somewhere, if I send my lecture through Zoom, then it goes out from my laptop only, right? But my Raspberry Pi does not have Zoom, and also, although it might have Zoom, then I need to connect and disconnect, and you guys log in and log out. That's a lot of problems exist. Therefore, I recorded. So first, this the second one is group. Now created. This video explains Linux commands, some of the Linux commands. So you can practice this. And I have some of the high speed. If it takes long, then I said, if you see here high speed, then it goes. We don't need to wait, right? For example, your Raspberry first needs to update and upgrade. Then updates takes a short time, but upgrade takes a longer time. Sometimes it takes an hour. So I sent it high speed to save time.
Take 5.
Some of the lecture here. How you can use editors. There are these kinds of editors available. But I am using VI. So you may use a VIM or Nano, Pico as you wish. So you guys need to practice. Choose one and practice somehow. But I recommend you to use a VI. If you follow this, then I will explain.
Because my account is all this CD. Oh, by the way, I want to make it. We need to finish up our way. And then same 21.
So it takes it's about 1 hour lecture, but if you practice this, probably maybe at least 2 hours as you practice.
Yeah.
If you do not have a Linux experience. All right, so I want you to do this.
1 second on, 1 second off. Okay, so
and then another lecture following here.
Once you download the BNC viewer and installed, be connected to change the content, but we can see point 1. I believe we were talking about we are
so some of the LED real
okay. Yeah, setting like that.
Sensor.
Okay. We remove that 2 letters and insert Control C to the top.
So I have a multiple LEDs and some of the orchestrating the LEDs.
Alright, that's where is I need to.
Maybe here.
Yeah.
So it turns on and off some sequence.
Sorry about that. If I interrupt, then
and then another one is distance sensors. ID, so you can follow it.
1.
And sort of debugging shown.
Active.
This is motion detection.
When I'm going to go into the and then I will do sleep PT like this. Like this.
Sensor. The motion can be detected.
No, nothing.
All right. This also about a little bit over 1 hour. We're not going to deal with all kinds of different sensor hands-on practice, but basically we start with small. I wanted to start with the LEDs, right? Once you get familiar with some of the wiring, scripting, and executing, then you can. I want you to practice by choosing one sensor. The sensor that I want you to choose, motion detection, distance sensors, and many other sensors available, right? Some of the health-related sensors, or photo sensors, or temperature sensors, humidity sensors. So those sensors, as the data collected, then the next module is how we can post the data to the cloud server. Okay, so your data will be loaded onto the server. That is the first step that we are doing. A lot of things that you have to do at your side, as I did. It takes time. So this, I will post one homework assignments, but that's I'll give you plenty of time. Okay, even if we start iPhone coding exercise, you can still work on this. So until we find we are ready to download your sensor data from the server. Around that time, under your name and your sensor data needs to be loaded on the cloud server database repositories. Therefore, your iPhone app, the code may be able to download data from that database. The format of the data that we download is a JSON format. So your iPhone code needs to break out the JSON code and then display on your iPhone apps. So a little bit of, at this point, maybe to you, so much difficulties in front of you, but actually you finally may be able to see, hey, that system runs that ways, okay? You clearly understand how data moves around. Knowing this, eventually you may be able to see how remote sensors, remote data may be able to be captured at one side and loaded into another side. Remember that recently there is a spy balloon from China community parties, and they sent out a lot of balloons, spy balloon, all around the world, right? So my home government, which is South Korea, they also had a lot of tensions. But anyway, so that is the same thing, right? On that balloon, there may be some of the sensors try to collect some sensitive information from the US territories. Collect that data, and then there may be some of the powerful microcontroller that send out data to China, and China receives the data, and without having to fly over any sensitive region, they can collect the data from there, right? That is the sensor networks, and on all this, what we are trying to do is widely used, okay? More microscopic application, for example, Tesla automobiles. Then Tesla has a lot of sensors installed already on each vehicle, right? So collect the data. If that is full self, what is that? FDS? Full self, it's not autopilot, a little bit advanced, right? So some road conditions maybe detected by so many other cars, because cars are moving around. Not only my car, some other cars already collect some data. Data shipped to Tesla server. So Tesla back-end server understands all details about road condition all around the country. So if someone wants to drive, it is self-driving, right? Fully self-driving. FSD, maybe, yeah. Fully self-driving. That Tesla car may be able to drive fully automatically by itself, not understanding the road conditions just right on time, but already know that road conditions somebody collected 1 minute ago, or 1 day ago, or a year ago. So database already understand some of the histories, some of the current states. Not only that, the road conditions, one section in front of that car or behind that car, because cars are running. And then sensor data are collected. And those data may be able to reuse. Okay, the sensor data collected by someone else may be used by my car. All right. So practice this at your side. It may take maybe 1 week, may not be enough. Then you can use 2 weeks at most. But homework assignment maybe a month or a month and a half. Don't get stressed too much. Still takes time. You have to, when you choose one sensor, then you have to learn. You have to understand that sensor carefully. Therefore, you have to wire that sensor into your Raspberry Pi. And then you have to script, you have to code and execute it. There may be some calibration needed depending upon the sensor. Then you need to practice it. For example, the motion detection sensor, then you have to calibrate in what type of motion that you want to sensor. Okay. I think I will stop. Any question